Excellent.
We'd like your honest opinions.
This punch is too sweet.
Your blouse makes you look fat.
Opinions about the ads.
This is a microscopic photograph of the surface of a video disc. The craters you see are really minute pits, the information source of the system. On a typical half-hour disc, there may be as many as 14 billion of these tiny indentations arranged in up to 54,000 circular tracks. A beam of light focused down to 1/30,000th of an inch passes through the plastic layer, striking the pits, which interrupt the reflected beam. This on-off reflected beam is then translated into electronic impulses. Each of the 54,000 circular tracks is equivalent to one television frame, making it possible to have as many as 54,000 individual pictures on one side of the MCA video disc. And when the optical reader head is programmed to play the same track over and over again, a freeze frame results. However, since there is no physical contact, only a low-powered light beam bouncing off the surface, the disc can be held in the freeze frame mode for as long as you wish, without any harm whatsoever to the disc. The 1,000th play will be just as clean, bright, and sharp as the first play. The optical reader can also move one frame at a time, either forward or reverse. This is called frame step, or frame-by-frame display. In addition, slow motion is possible by repeating a series of frames. The rate of slow motion depending upon how many times you repeat each frame before the optical head moves on to the next. Finally, each frame of the disc is encoded with a reference number, similar to a page number. This is done at the time the disc is mastered, and is the device used in order to take full advantage of the MCA video disc player's most outstanding feature, the ability to search out any given frame at any time. The video disc you are now watching began with the production of a glass photoresist master. Chosen because of its uniformity and freedom from blemishes, the plate glass is ground and reground with extremely fine abrasive to remove all pits, then optically polished and carefully cleaned. Finally, a thin, uniform layer of positive photoresist is applied to the glass in preparation for mastering. Either videotape or film can be used as program source material, and all master recording is done in real time. Here we see the actual recording of an optical video disc master. The program material is being supplied by a helical scan videotape machine. The blue beam of light, modulated to carry the program material and critically focused by the optical system, records the information on the photoresist-coated glass master disc. The sound and picture information are combined in an FM signal, used to modulate a laser beam, which alternately blocks or passes the beam focused onto the photoresist layer of the rotating master disc. Discrete microscopic areas are exposed at rates of up to 10 million per second. Development of this exposed photoresist layer creates microscopic holes in a spiral pattern known as the track. Each revolution of the track is separated by only 65 millionths of an inch. These holes contain all of the information necessary to provide excellent picture resolution, color, full fidelity sound, and synchronization signals. Once the master photoresist has been recorded and developed, the recording surface is metallized with an evaporated metal coating, after which additional electrochemical processing produces a nickel mother, as well as a submaster identical to the master. The final tooling, called the stamper, is a mirror image of the master, and is used to manufacture plastic replicas which produce in every detail the pattern on the master. Millions of these replicas can be produced with multiple submasters and stamper. The disc you now see being played was replicated by injection molding. In this type of replication, the stamper is placed in one half of a special injection molding tool. after which the two halves are clamped shut, forming a cavity the exact shape of the finished video disc. Hot molten plastic is then injected under high pressure to fill the cavity. When it has cooled and solidified, the mold is opened and the disc removed. Application of a metal reflective layer and plastic scuff coating results in a finished side, which is then bonded to another side to form the completed video disc.